Hello, knowledge seekers. Welcome to Remedial Tutorial Academy. If we take a complex number z, it can be expressed in terms of its real part and its imaginary part, x plus iy. And we got a sketch here on an Argand diagram of the complex number z. Now, if we took the modulus of z, say with these two lines down here, it represents the length of z, and that was given by, say, r. And if we had the x and y values and the angle theta here, remember theta was the arg of the complex number z, and it had to be an angle between minus pi radians and less than or equal to pi radians, then I showed you by trigonometry that in terms of x and y here, we can work out that the cosine of the angle theta would equal x over r, the adjacent side over the hypotenuse. And you could rearrange it to give x equals r cos theta. And similarly, you could find y by doing the sine of angle theta equals the opposite side over the hypotenuse. So that'd be sine theta equals y over r. Rearrange that, you get y equals r sine theta. And when we put these two values for x and y into this equation here, we generated another form of the complex number, often called the modulus argument form, this one here. So as x would be equal to r cos theta and the y was r sine theta, you can see I factorized it by putting r out the front. But there's another form that we can turn to for complex numbers, which is very useful when we're doing some harder work on complex numbers. It is this. It is that z can be expressed as r e to the power I theta. Now, I'm going to show you how we get this result. Not that you necessarily have to prove it, but I will show you how it's done in this video. But certainly learn this result here. Remember, e is the constant that you should be familiar with. E is roughly 2.718 and so on. Okay? So, how do we go about proving this result? Well, let's just put here proof. What we should know, or you might study it later on, is that it can be shown through something called McLaurin Series that cosine theta is identical to 1 minus theta squared over 2 factorial plus theta to the power 4 over 4 factorial minus theta to the power 6 over 6 factorial, and so on. You can see that the signs oscillate, so it's going to carry on like this. The next term up would have been theta to the power 8 over 8 factorial. Then it would go minus theta to the power 10 over 10 factorial, and so on. It can also be shown that sine theta is identical to this series, theta minus theta cubed over 3 factorial, and this one oscillates in sine. We now go to theta to the power 5 over 5 factorial, and then minus theta to the power 7 over 7 factorial. And it's going to carry on like this. Next term up would have been theta to the power 9. Plus theta to the power 9 over 9 factorial, and so on. And another series that we can show by McLaurin series is that e to the x turns out to be 1 plus x squared over 2 factorial plus x cubed to the 3 factorial, and hopefully you can spot the pattern in this one, because the next term will be plus x to the power 4 over 4 factorial, and so on. Okay, now all of these series here, I'm just giving you without any proof. As I say, they are proof through something called McLaurin series. Now, so what can we do with these? Well, if we were to take this series for e to the x, and we were to let x equal I theta, then we would replace the x here with I theta. We would therefore have e to the power I theta equals, now I'm going to have to write it's quite small because there's quite a lot of terms that are going to come up here, but it's going to be 1 plus x, which is now I theta. I'll just write that in brackets. And then we got plus x squared over 2 factorial. So it'd be plus I theta all squared over 2 factorial, and then I theta all cubed over 3 factorial. And hopefully you can get the sense of all these terms. Okay, next one is going to be I theta to the power 4 over 4 factorial. We'll put another one in as well, plus I theta to the power 5 over 5 factorial, and so on. Now, what I want to do next then is just clean this up. First term then is 1, and then the second term we've got I theta. Now for this third term, remembering that I is the root of -1, we've got I squared, which is going to be -1, so you're going to get minus theta squared over 2 factorial. And then here we've got I cubed, theta cubed over 3 factorial. So I cubed is going to be -I, so we get minus I theta cubed over 3 factorial. I to the power 4 next, well, that's going to be +1, and so we end up with plus theta to the power 4 over 4 factorial. And finally, for this last term here, we've got I to the power 5, which is going to be plus I, and then we've got theta to the power 5 over 5 factorial, and so on. Now next, what I want to do is just group up the real parts and then the imaginary parts. So we've got for the real parts 1 and then minus theta squared over 2 factorial, and then theta to the power 4 over 4 factorial, and so on. Okay, so I put that plus and so on. And then for the imaginary part, so I'll just put plus I being a common factor here, and then we've got just a theta there, and then minus theta cubed over 3 factorial, and here we've got plus theta to the power 5 over 5 factorial, and we'll put and so on there. Okay, now do you notice that when we look at the real part here, it's the same as the series here for cos theta. The next term here would have been minus theta to the power 6 over 6 factorial. This term here, and when we look at the imaginary part, you can see the 3 terms here are contained in the series for sine theta. If we had carried this on, the next term here, it would have been minus theta to the power 7 over 7 factorial. So what we've got then here is the result. This is the same as cosine of theta plus I sine of theta. So you can see then that e to the power I theta results in cosine theta plus I sine theta. So when it comes to writing the complex number z, that was in the form r times all of cosine theta plus I sine theta, we can now change it to z equals r times e to the power I theta. So this is another form that we can use to express complex numbers. Thanks for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every day. Don't forget to subscribe and share for your friends and classmates. See you next time.